Hi, welcome everyone. My name is Daphne. I'm from MX4, and I'm here to talk about how we integrated an automated metadata reporting system, which stores our data into SciCat. Thank you, Carlos, for the introduction of SciCat. I hope you all know what it is now and what it can be used for. And I will dive more into how we implemented this at MX4. I'm part of the control system group. We have a project running called Datastamp, which one of their aims of the goal is to implement this fair data policy here at MX4. So data should be findable, accessible, interoperable, and reusable. And we try, one of the ways we try to do that is by implementing SciCat into our systems. Because SciCat is, like Carlo already mentioned earlier, is designed to support the entire life cycle of metadata. And as also Carlo mentioned earlier, every facility has their own way of ingesting data into this database. And this presentation will mainly be about how we integrated how we ingest the data into the SciCat database. So we thought the cat can't be alone, so we decided to design a whole zoo around this. So we have the cat, the scientific catalog, but we're not as exotic as in South Africa. So we have a dog, the scientific data organizer GUI to help with that. Besides that, we also need a fish in our zoo, the scientific form implementation service helper. The acronyms are getting worse at this point. We have a toad that also helps us as a tool of attesting the data. And last, our newest member of the zoo, we've got to keep a close eye on him because it tends to fly away, is the SciFly, the file listener. Acronyms are not our strongest part. So the point of SciCat is to support the whole lifecycle, so from creation. So we first have to figure out what kind of metadata do we want to store. We have a bunch of variables that we can get from places like where the proposal is and some metadata about that. But every user comes to our facility with different aims, with different experiments. So we have SciDog, which is our scientific metadata configuration tool. It's a small web app based on React JavaScript, where they can basically fill out a form. It connects through a GraphQL Tango database backend from WebDrive, or Runtime, it's called these days, to retrieve the Tango devices, which are in the database for that Beamline. And they can write up their own configuration. So the Beamline can store this configuration, they create new configurations if new users come, and this is updated real time. So every time an experiment is run, it queries this SciDoc to kind of see what is the current active configuration and to see which metadata needs to be stored. So the Tango devices, they have an attribute, which can be interesting. So it could be multiple attributes, like for example, in this example, there's the sample one, where they want the description and the concentration, but they also might, for example, want the temperatures, which is in degrees Celsius, so we can add a unit to that, and give it a custom name, because our Tango devices are also based on where they're located in the facility, so names might not make sense to the users, so you can give it their own name. And they can also group them together if they want. So this is all stored in a JSON object, which then later also goes to SciCat when it's filled out. So it's from the creation to during a scan. So metadata is automatically harvested during a scan. One way is we connect to Duo, the digital user office, for proposal information. We have the proposal so we can get information about the abstract, or this also determines access rights because users have to log in with their account. So they can only see scans which belong to their proposal, from the Tango devices, which are configured in SciDog, and from, in this case, I used Sardana as the example for the control system, because that's the main control system we use at MX4, and for information about the scan, like think of a scan ID, or where the files are stored, which detectors are active at the time of the scan, those metadata. And it's all combined into one JSON object, which is being sent off well, that's what the SciFish does, that creates the JSON object and sends it off through a Kafka consumer, which then handles the data, fetches more data and ingests it into the SciCat database. Then we have the toad, which likes to show the data. So we build our own custom front end besides the SciCat front end, which is more minimalized and more aimed for what is happening during a scan. So it's kind of a table overview, as you can see here. And the user is free to determine what they want to see. So if they're not interested in the principal investigator, they can just hide the field. They can drag things around however they would like. There is a well, there is a comment section where they can write things about their scan. So they can say if things went well, things went wrong, or just small things they want to know that was happening during that type of scan. And they have the data quality metric, so they can rate their scan from 0 stars to 3 stars if they really like the scan or if something went wrong. So they can also sort and filter by that. So when they do data analysis, they can just quickly go back to this page and see, oh, right, these were the scans I want to analyze. And these were something happened, so I rated them 1 star. So this overview is more used for real time during scanning and later to come back to that. And whereas the SciCat has its own web-based front end as well, but it has a lot more features, like you can publish the data sets from there, and you can look into more detail of a certain data set. And we have a link to every data set as well in this table, so you can easily see the whole overview of the scan. Then the next step will be data analysis. Services such as Jupyter Notebook can be connected to analyze the existing raw data set. This is still a work in progress at MX4. We've recently started talks with the scientists on how we can implement this and what we can do. I know at ALS they have more experience with this, and they have the Jupyter Notebook system set up to SciCat. So this is something we are currently working towards, to have this included into the SciCat system as well, and to publish a data set. So from here we can also give it a unique identifier, a DOI to be traceable, and publish it. And currently we are in the panels search engine to find the data sets, the data sets can then be linked again to the SciCat. So you have the overview page of the scan, and you can download it. And the downloading is also linked through our Globus system. So we have the same system where you can download the data sets again. So they're not stored directly into SciCat, the data files, just the metadata, and the data files are again being downloaded from our central storage. So to have an overview, so the user triggers or starts a scan. So it can either be in the control system Sardana we use, or in other control systems, like for example CNSS. That's where the fly comes in, because the fly will recognize that the file is being written by another control system. They collect that metadata. The SciFish asks the dog for what configuration is active and gives it on to the cat, which then again tells the toad what to show. And from the SciCat database, you can publish it to currently with a DOI to the panels engine, and from the SciToad or Scanlog web interface, we can also export the data into our internal systems, which is eLoggy, our electronic logbook, where the users usually take notes. So they can generate an HTML table, and it will directly be stored into this logbook. Or they can export the metadata also to a CSV file if they want. Then a bit about the deployment. So we have automatic deployment set up for SciCat. So we have our internal CI pipelines in GitLab, which trigger some Ansible playbooks, which then again deploys these Docker containers onto our servers. Our consumers are running in Kubernetes. And they're also configured and set up. So we also have our logging system and everything connected to this. And we also have the automatic deployment of the SciDoc and the SciToad in Kubernetes. So basically, when you work on a separate branch, it will spin up a test instance directly into our Kubernetes development cluster. And if you tag a new version, it will automatically update the current production deployment of SciDog or SciToad, depending which one you were working on. So it's all done automatically and run in Kubernetes. SciFish is a Python package, or a Conda package, depending on which Beamline is running. We're currently using both. And it's in the Sardana Conda environment with a wrapper around that to become a Sardana recorder. And it's deployed through our Ansible playbooks. And in Sardana, it can easily be activated by saying you want an additional recorder and you select the SciCat recorder. And it will run in parallel with your existing scan. So it will also write the HTML5 files. And it should not interfere with the systems that are currently running. Let's see. Yeah, a little bit about the MX4 strategy. So we work in an agile way. So we have a 2-week turnover of feature requests. Most of these feature requests came from scientists. For example, we just had a static configuration file of which metadata they want to load into SciCat. But then we got regularly requests, hey, can we have this? Can we have that? And we want to update it. So that's when SciDog came to life to give them more autonomy and to free our time from currently always updating these configurations. It's currently implemented in 12 out of 16 Beamlines at MX4. Since we have a few custom control systems, it's currently integrated within, besides Sardana, 4 other control systems. So we have a few more to go to have it everywhere at the facility, but we're getting there. For the future, we try to provide a solution for the other control systems that we have. And we are working on implementing the data processing and analysis pipelines right now. And publishing of datasets in more data portals, so as OpenAir and B2Find. We want to include those as well. And that's it. Thank you for listening. Are there any questions?
It's funny and interesting presentation. Well, we have room for 2 or 3 questions.
Yes, I can. Thank you for publishing your data in Panos. Portal. It's highly appreciated. No, my question was about the Jupyter notebooks. You say that ALS, or you're thinking of providing a service that you link SciCat to Jupyter. What do you mean by that? Is it simply opening a notebook on the data, or is it actually something more?
So that's what we're currently investigating, how they're doing that and how we can integrate it as well. So SciCat doesn't store the data files, it just has a reference where the file is on disk. So we have to figure that, HTML5 file and sort of link that so we can implement it with our Jupyter notebooks. But right now they're not integrated at all. So from the SciCat web interface, you cannot go to your Jupyter notebook and do your analysis. So we are currently investigating how we can create that link. So it's within our current systems because we do have some services with Jupyter notebooks at MX4 to do data analysis, but they're not linked yet. So that will be the next step. I hope that answers your question.
Any other question? No, I've got one, the last one. You said that you are gathering many sources to be ingested into SciCat, and in the end you said that you can even push this metadata into the e-log. Are you also considering to have a log referenced in SciCat metadata?
Currently, we haven't considered that, mainly because eLogi, the logbook that we use at MX4 is used for many things. So even if we make a software upgrade, we write an eLogi entry saying, oh, we've upgraded this, you should use it like that. But users use it as well, and they have only access to their logbook. So it's a very well commonly used system at MX4 that we try to integrate this with SciFish. So we just use that one.
Okay, thank you.